You ever stop and think about how your favorite online store can handle millions of people during a massive sale? Or how weather apps can predict a storm almost to the minute? Well, the secret sauce is this really powerful, kind of invisible force called cluster computing. And today, we're going to pull back the curtain and see exactly how this super team of computers actually works.
I mean, just think about it for a second. We're talking about problems that are just massive, like forecasting weather for the entire planet, or rendering those insane special effects in a blockbuster movie, or even just handling all the clicks and buys on a huge shopping site. Your laptop, no matter how beefy it is, would just... nope. It will completely grind to a halt. So what's the move? What do? Well, it's simple, right? You build a team. If one person can't lift something super heavy, you get a few friends to help. And that's exactly the idea behind what we're talking about today. Computers do the same thing. They team up to tackle jobs that are way too big for just one of them. Because the reality is, for some of the biggest challenges in our digital world, one computer just isn't enough. It's not going to cut it. The sheer scale of the data, the complexity of it all, is just completely overwhelming for a single machine. And this brings us right to the solution, the computer super team, or, as the tech world calls it, a computer cluster. So what exactly is it? Well, cluster computing is basically a collection of connected computers that all work together so closely that they act like a single, super powerful system. And that's the key thing to get here. Even though it's made up of lots of individual computers, we call them nodes, they're all linked up, usually with a crazy fast network, and they act in perfect sync. It's one big, powerful brain made of many smaller ones. And this team, it's got a really clear structure. You have what's called a master node. And you can just think of that as the team manager. It's the boss. It takes the big, messy problem, breaks it down into smaller, manageable chunks, and then hands those tasks out to a whole group of worker nodes. These worker nodes, they're your team members on the ground, each one hammering away at their assigned piece of the puzzle, all at the same time.
Okay, but here's the thing. Not all teams play the same game, right? And it's the same for computer clusters. Depending on the job at hand, a cluster can be set up to run a few different kinds of, well, let's call them special plays. Let's take a look at the three main strategies they use.
First up, you've got the power play. This is for what's known as high-performance computing. And this strategy, it's all about one thing and one thing only: raw, brute force computational power. We're talking about solving the most mind-bendingly complex problems you can imagine. So the secret sauce here is a concept called parallel processing. Instead of one computer just chipping away at a massive problem, step by step by step, you have hundreds or even thousands of these nodes all working on their own little piece of the problem at the exact same time. Think about it. It's the difference between one person trying to build a skyscraper and an entire construction crew working together. This is how scientists can simulate crazy complex physics or build those incredibly detailed climate models.
All right, next up we have what I'm calling the efficiency play, or load balancing. Now this one isn't about solving one single giant problem. It's all about handling a massive, massive flood of small requests all at once. Just picture a huge e-commerce site during Black Friday. You've got millions of people all trying to get on at the same time. A load balancing cluster acts like a super efficient traffic cop. It sees all that incoming traffic and just starts directing it across many different servers, making sure that no single one gets totally overwhelmed and crashes. This is literally the reason your favorite websites don't just collapse when they get super busy.
And finally, we've got the safety play. This one is all about reliability. This is for the kind of systems that just cannot fail ever. So in these high availability clusters, you basically have backup nodes that are exact copies, just sitting there, waiting, ready to go at a moment's notice. If a main node fails for any reason, could be a hardware glitch, could be a software bug, a backup node instantly, and I mean instantly, takes over. For you, the user, there's absolutely zero interruption. This is so crucial for systems where failure is not an option, like banking networks or hospital databases. Okay, so we've got these different strategies, these different plays, but how does the team actually coordinate all this? How do all these individual computers talk to each other and know exactly what to do?
The real magic that holds this whole team together is a special kind of software called cluster middleware. So if the master node is the team manager, you can think of the middleware as the super organized project manager. It's the software layer that handles all the nitty-gritty details. It manages all the shared resources, it schedules all the tasks across all the nodes, it even detects when one of the nodes fails. Honestly, it's the true brains of the whole operation, making sure the entire group works as one seamless unit.
Now, like any super powerful technology, building one of these computer super teams has some pretty clear wins, but there are also a few trade-offs you have to think about. All right, let's break down the wins versus the losses here. So, on the pro side, the performance is just out of this world, obviously. But it's also surprisingly cost-effective when you compare it to building one single gigantic mainframe computer. They're also really scalable. If you need more power, hey, you just add more nodes to the team. Easy. But on the con side, that initial cost to buy all that hardware can be pretty steep. And these clusters, they take up a lot of physical space and they are thirsty for power. I mean, they consume a ton of it. And this is a big one. They can have a single point of failure. Unless you've built in that redundancy we talked about, that safety play. If your main master node goes down, the whole cluster can be paralyzed.
So you might be thinking, this all sounds really high-tech and, a bit distant from your daily life. But the truth is, you interact with the results of cluster computing pretty much every single day.
That weather forecast you just checked on your phone? Yep, that was crunched by a high-performance cluster. That super smooth experience you had shopping online last night? That's a load-balancing cluster at work. And, oh yeah, the mind-blowing special effects in the last blockbuster movie you saw? You guessed it, rendered on massive clusters of computers. From huge scientific breakthroughs to the entertainment we love, these invisible teams are working behind the scenes literally everywhere.
So the next time you use a piece of tech that just feels impossibly fast, or you see something that's handling an incredible amount of data without even breaking a sweat, just take a second. You're probably witnessing the work of one of these amazing computer super teams. And it leaves you with a cool question, right? Now that you know they exist, where else are these invisible super teams at work?